a ver la unidad 4, Unit 4.
Ajá, en este caso
Discussion.
vamos a iniciar, bueno, ya habíamos iniciado la unidad 4,
Ujú.
este,
Sí.
pero habíamos avanzado solamente los dos primeros temas.
Eso fue
En
como una
este caso,
introducción.
vamos a la tercera entrega de esta unidad. De hecho, el título lo tenemos en pantalla.
Sí.
Y pues vamos a desarrollarlo, ¿verdad? Hacer toda la introducción y parte del desarrollo. Ver
Ok,
hasta dónde nos rinde el tiempo.
claro.
Okay.
Ujú.
So, to
Ok.
start talking about discussing dimensions and
Precision.
precisions.
Ok.
Okay, and something that you should know, and I'm
Ujú.
gonna make a change in slide, is the next thing. So,
Ok.
when we talk about dimensions and precisions, during this section, we're going to talk a lot of something known as tolerance.
Ujú.
Okay, now you may say, okay, what is tolerance? And it's in parentheses, it's permissible deviation from a specified ideal measurement or value. That's known as tolerance. And in this case, tolerance is dealt with in the context of linear dimensions.
Ujú.
However, the concept of tolerance can be applied to most types of measurements and values in engineering.
Ujú.
You might remember that the last section of the Unit 4 was actually the scales, the systems, and the drawings. Okay, so when we use and work with the drawings, you might remember that we saw the centimeters,
Yeah,
meters,
millimeter.
um, and the different
Chess.
drawings like elevations, cross section, schematic, exploded views, and stuff like that. So,
Yes, in this case, it was for different systems like English system
the
or
American and the European
American.
system.
Okay.
And of course, we talk about measurements, but now we're going to talk about how we're going to use those measurements in the design of the same drawings of the same ships, buildings, devices,
Mhm.
cars, maybe systems could be, and stuff like that.
Okay.
Now, in electrical applications, the frequency of an alternating current may be allowed to vary within a specified tolerance. For
Mhm.
example, plus minus zero point 0.2 hertz. Or in manufacturing, the temperature of the production process
This
involving
one.
heating may be allowed to vary between a specified temperature range, for example, plus or minus 2.5 Celsius degrees. So we have two different perspectives in the manufacturing process, in this case, the production, and if we talk about electrical applications. Now,
Okay.
in all the engineering process, we have the tolerance. Of course,
Mhm.
it's different from one range to another. So that's where we have to know, okay, that
Mhm.
according to our work area,
Mhm.
what is tolerance for us, okay?
Okay.
And during this second part of the Unit 4, you will find the following vocabulary useful in this section.
Okay.
Okay, I'm gonna use my spotlight so that you might notice it. You have words like accuracy,
Accuracy.
accurate, and of
Accurate.
course inaccurate. It's the opposite
Mhm.
of accurate.
Yeah.
You have precision, precise,
Precise.
and imprecise.
Imprecise.
Okay.
Mhm.
And you've got all the words that have to do with tolerance. With
Tolerance.
tolerance, I would say tolerance plus or minus.
Yeah.
That is something that I mentioned before, plus minus zero point 0.2 Celsius degrees,
Yeah.
plus or minus 2.5 Celsius degrees. Okay.
Okay. Okay.
And something that will work later, it's known as the tight tolerance. Okay. Tight
Huh?
tolerance.
Yeah.
And then we got some descriptions such as length, the wide,
White.
height,
Right.
thickness, depth, long, short, wide or narrow, high or low, thick or thin, deep and shallow. Okay, and the diameter and radius when we talk about
Radius.
circles, because we have a practice with circles actually.
Sure.
Some of the words
Okay.
to describe dimensions are familiar to students at this level. I mean, long, short, and stuff like that.
Mm-hmm.
And these terms are included to highlight the link between the adjective and nouns, like long
Okay.
is a description and the noun
Mm-hmm.
is length.
Yeah.
Or the opposites, like the antonyms, like
Yeah.
depth and shallow.
Okay.
Okay, so we're gonna work with a lot of these words like adjective, nouns, synonyms, opposites,
Okay.
and stuff.
Sure.
Mhm. So
Okay.
something that you might know right now that we are gonna work with. Mhm. Okay, so in this case, just for us to continue, let me just activate my camera so that you might see it to me. And there I am. Okay, let's start with the first part in here. The book tells us to have something known, and I'm gonna change accuracy and precision. So my first question, the first question that we have to sum up with this, it's what do you know of the meaning or maybe an example of accuracy versus precision? Because some people might say that they seem like synonyms, accuracy, precision. So what do you know? What do you understand of these two different concepts?
Well, accuracy and precisions. Maybe I understand that accuracy is when I don't have a range. I mean,
Mhm.
I don't have minus or plus because I need one value for give forgive I don't know like
Mhm.
readings or another dimensions that I need to use. But I think is that my idea about that. No, the other hand is precision.
Mhm. Yes.
Precision. Wow, precision is like similar but accuracy. But I feel that two words. Maybe the difference is that like structure, but for me is very similar. The precision, accuracy, accuracy. I need to check, but precision. In Spanish, I can translate accuracy like exactitud, exacto, or precision, but I don't. In this case, the precision. I think the precision maybe have maybe it has more range. I mean, in this word, I can use I don't know tolerance in accuracy. No, no, it's not similar. His I mean its function. No, but I think is the difference in precision. I can use a range in accuracy. I don't have that idea. No. I think is my thing. No.
Okay. Okay. Sounds great. Now I'm gonna play a picture. I want to look at it. Look, we have
Oh,
four different arrows, and both of them compare accuracy and precision.
accuracy, high precision.
If you see the first circle, the first arrow circle, you might see
High accuracy.
that all the crosses are in the middle, in the center of the circle. Now that means that we have a high accuracy and a high precision. But what will happen if we have low accuracy now and the same height precision? That means in this case, you might see that the crosses are not in the center, but they are close together on the
Yeah.
left side of the circle.
Mhm.
So something that you might notice in here is that accuracy is when the crosses are in the center, and precision when the crosses are together. Okay. Now, in the third circle, just below the first one, you have a high accuracy but a low precision. Now, in the same point, we have a high accuracy. That means the crosses are in the center,
The
but
center.
the precision means that the crosses are not close together. They have a small distance, but they are all in the center.
Yeah, yeah.
Now, in the last circle, you might notice that if we have a low accuracy and also a low precision, that means that the crosses are going to be all around the circle.
Around the center.
No in the
Okay.
center, not together. Why? Because there's no precision and no accuracy. So we might conclude this one, the difference between the accuracy and the precision, that accuracy, in this case, it's the degree of the closeness to the true value. Okay, that's accuracy. How close it's to the true value, to the point value, the I don't know, the goal, the objective, and stuff like that. Okay. Meanwhile, the precision refers to how close the measurements are to each other. Okay, that means precision is how close they are between each other. If we talk about measurements, or maybe an instrument and a measure, or an instrument and in this case, the product that it does. Okay, and accuracy would be in low cases that they are in the true value. That means all the answers go in the same way. That's why they are close together. Okay, so that's the difference between accuracy and precision. Okay.
Okay.
Accuracy, it's the closeness to the true value. Meanwhile, the precision goes to the closeness in the measurement of the instrument. Okay.
Okay. Okay.
Great.
We have another two examples below for this target.
In which ones do you mean?
So I understand better the the effect in this case for the two words, no? In this case for two words. Okay, no problem.
Okay, that's the main point of viewing here. So let me see. Okay, then we continue with an extension activity. So I'm gonna go move just right through the book. Tell me if you're looking at the book right now. I think you don't.
Yes.
Oh, there it is. So.
Okay. Yes, yes, I see that.
Okay.
I see that.
Perfect. So in your book, that's on page 32. In the exercise B, we're going to start in here. Let me just make a small zoom. I think this is enough. So in the second exercise, letter B, we have to read the technical advice web page and answer the following 3 questions. Could you please help me by reading the 1, 2, 3 questions, please?
Yes. Well, read the technical advice web page and answer the following questions. Number 1, how is a superflat floor different from an ordinary concrete floor? And number 2, what accuracy can be achieved with ordinary slabs and with superflat slabs? Okay. What accuracy? Okay. Number 3, what problem is described in high-bay warehouses? It is about the lesson, well, in this case, the superflat floors.
Yes. Have you ever listened of the superflat floor?
Superflat floors.
Have you ever listened of them? Well, maybe you have seen one of them.
Superflat. Well, I can imagine imagine superflat floors, but I don't know. I don't hear that before. It's just I can imagine that word. No.
Okay. We're gonna read and know an example so that you quite understand them. So
Okay.
I'm gonna read the first paragraph. Well, the first question and the first paragraph in this text,
Uh-huh.
and then I just want you to help me read it with the second question
Mm-hmm.
and the second paragraph.
Mm-hmm.
So it says super flat floors.
Okay.
What is a super flat floor? We might be asking. So, compacting and finishing the surface of wet concrete is an inherently imprecise process. For an
Mm-hmm.
ordinary concrete slab to be laid within tolerance, engineers can only realistically expect the surface to be finished to plus or minus 5 millimeters. By contrast, the super-flat concrete
Mm-hmm.
floors are finished to meet extremely close tolerances. That means being accurate to within 1 millimeter across the upper surface.
Oops.
Mhm.
Is good.
So we're talking a difference between 5 millimeters and then
Uh-huh.
1 millimeter.
Yeah, yeah, yeah.
Continue, please.
Is we talking about the roads or ways or
Mhm.
what kind of I mean what kind of structure we are talking about? I don't know, floors in the houses or in the buildings or
Actually, that's
or
something that you might answer in the paragraph that you're gonna read.
paragraphs. Okay, okay.
You might find the answer there.
Mm-hmm. Okay, so it's completing and finishing. The surface
Mhm.
of wet concrete is an inherently impressive process. Okay, for an ordinary concrete slab to be laid within tolerance, engineers can only realistically expect the surface to be finished
Mhm.
to plus or minus 5 millimeters. Okay, by
Yes.
contrast, super flat concrete floors are finished to meet extremely close tolerances. Okay, being accurate to within 1 millimeter across their upper surface. Good,
Mm-hmm.
yes, yes, yes. That you explained that.
Uh-huh. Then the second paragraph has
Mhm.
a question. It says, where are super
Super
flat
flat floors
floors
used.
used? You were
Used. Okay.
asking of what we are talking about. I mean, houses, buildings, and actually, the super flat floors are used in something that you might know as
Uh-huh.
warehouse. I don't know if you've listened the word warehouse.
Mhm.
For example,
Yes, yes. Warehouse is common for me.
yes. Well, the
Yes.
surfaces that the warehouse have are super
Yeah.
flat floors.
Yes,
Okay.
it's necessary
Mhm.
in that areas. It's important
Yes. So could you
for
please
the.
help me reading aloud the paragraph, please?
Okay. Floor surfaces with extremely tight tolerance are frequently specified in warehouses where automated guided vehicles operate. Okay, like lift truck. This is
The
one
lift
example.
trucks and stuff like
Yes.
that.
However, floors are especially problematic in by warehouses,
Mhm.
which use automated forklifts. Here is with a vertical reach of 30 meters or more. At such a height, slight variations in floor level are amplified in the form of vertical tilt,
Mhm.
causing inaccurate maneuvering at high level. If these variations are outside tolerance, they can lead to collision with racking elements, yes, or cause items to be dropped from pallet. Yes, yes. This is the activity for these machines
Mhm.
in these areas. No, Yes.
Yes, so it's something really common, as you said, in the warehouses. As an
Yes.
example, where we use the AGV. And AGV, it's the automated guided vehicles. Okay,
Okay. Okay.
I don't know if you might have read before the Amazon centers or the Amazon delivery
Yes. Yes. I
centers
hear that.
use a lot of robots.
Mhm.
So these robots are automated guided vehicles because they follow
Okay.
a path, they follow a way. And this
Mm-hmm.
surface is a super flat floor because they lead them to have a better, in this case, operation as
Mm-hmm.
they are automated. Okay.
Mm-hmm.
And we
See.
also have the other ones that can be also human handed, as for example the forklift, the ones that have like two pins in here and they make like zoot, and they go
Yeah.
down and go up and stuff like that.
Mm-hmm.
So those forklifts actually also function inside a super flat floor, talking about warehouses.
Yep.
Mhm.
Yep.
So now that we read these ones about what is a super flat floor and where can we find or where are used, we might answer the three questions that we just
Oh,
read
yes.
upside. The first
Mm-hmm.
question asks us, how is a super flat floor different from an ordinary concrete floor? I'm gonna take out just my text pointing here so that I can write the answer. So please tell me, what's the difference between an ordinary concrete floor, like the house, the building, maybe the
Yeah. Yeah. Yeah.
street,
Yeah.
and a super flat floor?
Well, in this case, that is like you explained before.
Mm-hmm.
Maybe the tolerance, the tolerance is different because when I make this kind of floors, I need tolerance, different tolerance, and the surfaces are different too. And I have extremely areas that are being accurate in different surfaces.
Mm-hmm.
Uh, I think is that the difference, the main difference, no? Um, mhm. One more,
Okay,
maybe
well,
the
for
materials is,
uh-huh.
I think is are different too. Um, mm, yeah, well, mm, I need review or it's necessary uh, inspections, maybe uh, for different periods. No,
Okay.
I think that.
So as answer to the first one, what's the difference between a super flat and an ordinary concrete floor?
Yes.
We might say that a super flat floor has a much flatter surface.
Mm-hmm.
Flat, it's like liso or
Yep,
plano.
yep, yep, yep.
So if we say that it has a flatter surface, we might remember the flat concrete, el concreto pulido, that it's
Uh-huh.
like all flat, and you can slide your finger like this, and it
Mm-hmm.
moves easily because it's flat. It has like no
Mm-hmm.
friction, almost no friction. So
Exactly.
that's the super flat floor. Why? Because if you go actually right now to your floor of the house and you do this to the concrete, you
Yep.
might see that you itch your finger.
Mm-hmm.
Okay, why? Because of the friction, and of course because of the material that is made. Okay, that's the difference. That a super flat floor um, has a much flatter surface. Okay, in
Mm-hmm.
this case,
Mm-hmm.
and
Okay.
in any other explanation of this one, I might say that it's finished a little bit more precisely.
Exactly.
Okay, so
Mm-hmm.
in the same case, it's finished. Let me just write it in here. It's finished more precisely
Mm-hmm.
than an ordinary concrete floor.
Okay, concrete floor.
Uh-huh. Now look
So,
at the second question. What did you
mhm.
say?
Well, now that you mentioned about the the floor, like so much flat, uh, I remember that rugosity, that kind of characteristics for the that for that
Mm-hmm.
I mean a special structure in the surface, no?
Mm-hmm. Like something that is rough.
Yeah, road. Okay,
Uh-huh. Rough. Mm-hmm.
road. Okay, good. Second is what
Mm-hmm.
accuracy can be achieved with ordinary slabs and with super flat. I mean, I think it's super flat
Mm-hmm.
slabs. Okay.
So let's talk about accuracy now.
hmm
What accuracy can you achieve? That means can you get with ordinary and super flat?
Okay.
Mm-hmm.
Well, in this case, it's necessary get uh, mm, get values that are being accuracy. Talking about ordinary slabs and
Mm-hmm.
super flat slabs, right?
So,
But
yes, so we're going to talk about a number actually. If you remember the first paragraph, they mentioned the
yes,
millimeters. So
1 millimeter,
that's
yes.
mhm. So well, 1 millimeter goes for the super flat slabs,
Uh-huh.
and
Super flat.
the
Five,
accuracy in an ordinary it's 5 millimeters.
millimeters. Okay.
So
Yes.
the answer would be for an ordinary. So
Mhm.
for an
For an ordinary.
ordinary, oh my god, ordinary, a slab that would
Mhm.
be the
Could be.
tolerant accuracy
Okay.
is up to 5 millimeters. Okay, remember it's a plus or a minus. Okay,
Okay.
plus, I don't know
Or
how to make the same
minus.
symbol, so I'm gonna just write like plus minus 5 millimeters.
Mhm.
And well, meanwhile, a super flat floor goes up to a plus or a minus of
One.
1 millimeter.
Exactly.
So that's the difference in accuracy that we can get achieved actually. And the third one, please.
Okay. The theory is what problem is described in height by warehouses, right?
Mhm.
Well, we say that the problematic is high high variation
Yes.
in floor, talking about the level are amplified in the form of vertical tilt,
Mhm.
inaccurate maneuvering, for inaccurate maneuvering in with lift trucks.
Exactly. So that's the problem.
Mm-hmm.
The answer in this case would be that the problem is a slight variation. Okay,
Mm-hmm.
a slight variation
It's like
in
variation.
floor level
Floor level.
can cause a
Uh,
forklift,
for lifts.
the forklift to tilt.
Okay.
Okay, to tilt. In this case, then the forks can hit racks, drop items, and stuff like that.
Exactly.
Accidents that may affect the production.
Yes. Um, I know that in this case, for the four lifts, it's necessary to use different tires. I don't know in this class and in this kind of floors, that tires is important because are different. I mean, no super flat floors. Is in one tire
Mm-hmm.
in where I don't use super flat floors. It's necessary a pneumatic tire. In this case, not. for super flat floors, it's necessary tire, a hard tire.
Yes.
Yes, it's interesting. It's interesting in this case.
So we might see, I have a photo of an example of a forklift accident. I'm gonna show it right now just in my camera.
Ah,
I don't know if you can look at it.
yes.
So that's a really common accident, and there is a video. I think you already watched this video. I don't know. Maybe yes, maybe you didn't. And it says this is a video that was shown in the worst. It's known as the worst forklift accident ever.
Ooh, worst.
I think you might already seen this video because it has a lot of general reactions in this one.
Yeah.
Let me just upload it out in here. You might remember this. Let me see if it's in here.
Okay. Worst for it.
So you might see in here. I don't know if you're able to see.
It's a warehouse.
Yes, it's a warehouse. So you might see there's like a man just below that and stuff like that. And you can see it comes a forklift.
Exactly, yes.
And it comes in here, it comes in here.
Oops, 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 oops. Oh.
And it crash and pull.
Wow.
All the material falls down. And it causes a change reaction. And look at the sides. Goes down, 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 down.
Oh, no.
Okay. So there it is. That's a warehouse accident, actually. The most common accidents that happen with a forklift. So that's why it's important, actually, to have good dimensions. And actually, the people who to manage to drive these vehicles will have to be like pro people driving these things and stuff like that.
Yeah.
May I erase this?
Yes, and always it's I want to say that always is necessary the training for that people.
Yes.
Training is important.
And I would imagine that those people is well paid. I hope, because I don't know, but I hope they are well paid. Yes, because it's like an ability. Okay, not everyone can manage one of those forklifts. Okay, and stuff like that. Great. Now, look at letter C. It says discuss what is mean by tolerance. Again, we're going to talk about tolerance, but now in the context of dimensions and precision. Do you know, and we know tolerance is when you tolerate, obviously, others people idea, others people religion, point of view, etc. But if we talk about dimensions and precision, talking about engineering process, what is tolerance? What is meant by tolerance? Do you know?
Tolerance?
What do you think about this one? And I'm going to make a change in here in this part. It says tolerance in context of dimension and precision. Could you please read what it's in the paragraph?
Okay, let me move this square for. Okay, in terms of measurement, the difference between the maximum and minimum dimension of permissible errors is called the tolerance. Okay, the difference between the maximum and minimum. Okay, the allowable range of errors prescribed by law, such as with industrial standards, can also be referred to as tolerance.
Exactly.
Okay.
So the main idea, it's the one highlighted in yellow. Well, the yellow highlighted, it's the difference between the maximum
Maximum
and
and
the
minimum
dimensions of
dimensions.
permissible errors is called tolerance. Now, I just want you to take a look at the picture that I just put below. Now, you have three different numbers,
Okay.
49.9
49.
millimeters, 50 millimeters, and 50.1 millimeter. Now,
Okay.
look at the one in the middle, the 50 millimeter. What is it? It says a standard product. So
Standard product.
all my products, all the production, the manufacturing devices need to be or need to have a 50 millimeter dimension, not more. But I have tolerance. What's my tolerance? 1 millimeter. Well, 0.1 millimeter. Again, a plus or minus 0.1
0.1.
millimeter. That means that 49.9 is my smallest acceptable product, and 50.1 it's my largest or my biggest acceptable product. That's my
Exactly.
tolerance, 0.1 millimeter. I can have 50.1 or I can have 49.9 or
49.9.
50. That's great. But I cannot go down and I cannot go up.
Okay. Okay. Yes,
Imagine
it's
I have a 50.3. No,
good.
that's
No.
not acceptable. It's 3 millimeters more. Well, 0.3
Okay.
millimeters more. So that's a lot.
Mm-hmm.
And that may affect my function of the product,
Yeah.
the procedure, maybe the utility of my
The
product. I don't know.
quality.
Mhm.
Quality
The
is
quality, the durability, and stuff like that.
exactly.
So that's something that we have to know when we talk about tolerance, okay? Something that you might know in here. Great, perfect. So
Exactly.
now that we know a little bit more about tolerance, talking about dimensions and stuff like that, let's just go back to our book and the exercise letter D. Uh, okay, there it is. And it says complete the following expressions from the web page which are used to describe tolerances. Now we have four different expressions. Number one says tolerance inside the limits of a given tolerance. Let's use the web page that we have just up in here. Let me just take a zoom in here. I think like this. Okay, like that. So in this text, we have to get four words that are going to describe the tolerances. Okay. So number one, tolerance inside the limits of a given tolerance. Okay. Which word help us to know this?
Okay.
Which word?
We have one paragraph. We have one paragraph with tolerance, extremely close tolerance, very accurate, be light within tolerance.
To make it a little bit easier, the first two expressions goes with the first paragraph, and the 3 and 4 expressions goes to the second paragraph.
Okay. So it's inside the limits a given tolerance. Okay.
A word or a connector that tell us inside this, no more, between this and this.
Maybe we can what we can say standard value or standard inside the limits of a given tolerance.
Okay, could be it.
Standard tolerance, no?
No. In this case, the expression, because we remember we're looking for expressions. The expression that tells you or refers to tolerance is a word that we have in here, within.
Within is okay.
Within it's an example of like a parenthesis. It's
Yeah, yeah,
inside
yeah.
these parameters. Okay.
Yeah.
For
Inside the
example,
limit.
a daily example could be when your daughters have an academic, I don't know, an academic travel or something like that, or an activity that they're going to visit a museum or something like that,
Yeah.
and the school tells you, hey, you as a father, you should take your children
Okay.
within 2 p.m. and 3 p.m.
2
So that's
p.m. and 3 p.m.
within 2 p.m. and 3 p.m. refers that between 2 and 3, not before 2 and not after 3 p.m.
Okay.
That's within. Within it's the same as between.
Yeah, 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 yeah.
Mhm. So that's the number one. You might write within.
Okay.
Maybe I can write it in here with these.
Within. Okay.
Yes, within. The second one, an expression that refers or, that means you got it in parentheses actually.
Is maximum or minimum or
In other words,
is plus or minus? Yes.
plus or
Or
minus.
minus. Okay.
That will be like the range. The tolerance range.
Tolerance, close tolerance. Okay.
Yes, I mean, like there is not a lot of possibility to tolerate more, just this, and that's everything.
It's tight.
Tight,
No?
exactly. Tight tolerance.
Okay, I understand.
And actually, we might say tight often refers to no tolerance. It's like just a 10% of permissible tolerance.
Yes.
Yes, and it goes like that. Where is it? Oh, here it is. Tight tolerances. Yes. And the last point, number 4, it says tolerance not inside the limits.
Auto garage in this case.
Outside tolerance. Yes. And I think that it was easy because it says outside. So yes, that's the answer. An outside tolerance. Great. Tell me when you finish, or did I erase it?
I'm good. I'm okay. Eh? I'm okay.
Yes.
No problem.
Okay. Okay. Perfect. Now, let's make just a little bit more of practice. Okay. Let me just move to a quick note. Let me just change to the PowerPoint presentation. Tell me if you're looking at the PowerPoint presentation.
Yeah, I see that.
Okay, so this is the note. Just before I finish and before we continue, the note says, remember, a tight tolerance can also be referred to as a close tolerance. The opposite of tight tolerance is a loose tolerance. Loose tolerance, in this case, it's that we have a lot of tolerance range.
Yeah.
Okay. Tight and loose tolerances are relative depending on the situation, of course. For example, in concreting, plus or minus 1 millimeter would be considered tight tolerance. Okay. And
slab or
and whereas in many metalworking applications, plus or minus 1 millimeter is considered loose tolerance. So it's the same difference, 1 millimeter, but in the concreting is tight tolerance. And in the metalworking area, it's a loose tolerance. I mean, you can have more millimeters. So that's the difference. That's why they say, they mention the tolerance is relative. It depends of the area, of course. It's not the same for the I don't know, the developing area than the manufacturing area and stuff like that. Okay, great. So let me just go back to the book again and stuff like that. Perfect. Okay. Now look at exercise E. Could you please read the instructions?
Yes. Complete the following sentences using the expression in exercise 6D. Okay.
Thank you. So the words that we just used before in here, this one, the one of tight tolerance, outside tolerance, plus or minus, and
Mhm.
within tolerance, those words, you're going to use them now in a
Okay.
real life application. So could you please
Okay.
read number one?
Okay. The frames too big for the opening. The opening's the right size, so the frame must be outside, no? Outside
Exactly.
tolerance. Outside.
The frame must be outside tolerance. Perfect. Now, number
Yes.
two says the
The number.
total tolerance is 1 millimeter. The
Mm-hmm.
permissible variation is
Side.
either side of the ideal is
5 or what? 5 millimeters or
which one
yes.
would be that one? It would be
Permissible variation. Okay. 5 minus no. Plus or minus, right?
exactly.
Yes, yes, yes.
Plus
Or
or
minus.
minus
Minus, yes. Minus.
5 millimeters. Well, 0.5 millimeters, 0.5 millimeters.
Oh, yes, yes. 0.
The
0.
third one, could you please read it?
Okay, 3. The engineer specified plus or minus 5 millimeters for the slide finish. Okay, and we got it to plus or minus 2 millimeters. So it's well permissible, no, tolerance, or no.
Which of the concepts?
Uh,
I
right.
mean, the engineer specified 5 millimeters
Uh-huh.
and you've got 2. That means that you are,
Yeah. Mm-hmm. Into the range, but
that means within.
in well within tolerance, right? Yes.
Within tolerance because you're in the same range. I mean, you're not more than 5
Mm-hmm.
and stuff like that. So you're within tolerance. And
Okay.
finally, 4.
Okay, you can finish concrete to plus or minus 0.1 millimeter. There's no way you can work to such a okay. I have you say it, tight no or tight
Yes,
tolerance, right?
tight tolerance.
Yes.
Because actually they mention it. You
Yeah.
can't finish concrete to plus or minus 0.1
Excellent.
millimeter. That's
Excellent.
that's a little of distance of measurement.
Yes.
So imagine to an engineer that tells you, I want a super flat with a plus or minus 0.1 millimeter of tolerance. So that's really difficult.
Yes.
You must be perfect.
Okay.
Then
Okay.
letter F, it's actually this one would be
Listen
the
situations.
homework.
Okay. Engineers describe stars.
Yes, let me just make a zoom. Oh my god.
Okay.
Here it is. Let me just
No
make a zoom.
problem. Huh?
Okay. It says F. In some situations, engineers describe tolerances using plus or minus. For example, plus or minus 1 millimeter. And in other situations,
Uh-huh.
as within. For
Okay.
example, within 1
One
millimeter. So
millimeter.
it's the same. You can say within or you can say
Within.
plus or minus. It's the same. It depends of the engineer and the situation.
Okay.
So I want you to discuss the difference. I mean, you can write it down. Actually, that's your homework to write down the difference in the meaning between within and plus or minus.
Mhm.
You can use examples.
Mhm.
Okay, I want you to
Okay.
think why
Yeah.
some engineers say within and
Mhm.
why other engineers say plus or
Or
minus.
minus.
Maybe because they have different work areas,
Mhm.
maybe because of the project,
Yeah.
maybe because they use, I don't know, in concrete aspects they use the plus minus, but
Mhm.
in the metalworking they use the within. I mean, it depends of the area, it depends of the material maybe. So I
Exactly.
want you to think that, okay, and write down what does it means within and plus or minus.
Good. Good.
Okay,
Okay. Okay.
so that's your homework for tomorrow.
Okay.
Mhm. Any doubts or questions until now?
No, it's interesting. It was interesting for me.
Yes, hope it was actually.
Yes.